Hello, welcome to Pre-Cal Lecture 1.10, where we're going to talk about rational expressions. And a rational expression, and if you want to pause the video to copy all this down, that's fine, but a rational expression is just a polynomial over a polynomial. So in the last section we talked about polynomials. So really think of it, a rational expression is really just a fraction with x's in it, or some variable. All right, the denominator of a rational function can never be 0. All right, so that's a big deal, and that's a big part of this lecture here today. The domain is all the allowable values of x. So what I really mean by that is it's all values that don't make the denominator equal to 0. Okay? Now the way that we're gonna express that is in a shortcut version. But let's go ahead and do some examples. So first example, let's say what is the domain of x minus 2 over x plus 5. The way I'm going to allow you to write that is, okay, so x cannot be what number? Well, it can't be negative 5 because that would make the denominator 0. So I'm going to let you write the domain like this. X cannot be negative 5. It can be any other number but negative 5. All right, so I'm not going to make you write out x is all real numbers except negative 5. We're just going to write it this way. Some teachers may make you write that out the long way, but I'm not going to. Let's do another example. So what is the domain of 3x minus 1 over x squared plus 2x minus 3. Okay, well, what we need to do is figure out what values of x would make this denominator 0. Okay, so we don't really care about the numerator. I'm just going to rewrite the numerator as 3x minus 1, but we could factor, just like we did last section, factor that denominator. And x, pretty easy. We've got x and x. And we also know that 3 is a prime number, so we can put a 3 and a 1 here. And I just need to have a positive 2 in the middle, so if I have plus and minus there. So I need to figure out what values of x make the denominator 0. Well, I can eyeball this and tell if x is negative 3, then this parenthesis would be 0, so that would make the whole denominator 0. Also, if x is 1, then that parenthesis would be 0, which would make the entire denominator 0 because 0 times anything is 0. But if it gets fancy, so that one's a pretty easy one to eyeball, but you could set each of these parentheses equal to 0 and solve. So x would be negative 3, and x minus 1, the second parenthesis is equal to 0, so x is equal to 1. So our domain, the way I'm going to allow you to write it in a shortcut fashion, is x cannot be negative 3 or 1. You can just put a negative 3, comma 1. It can be any other number except those two. All right, so that's what we're talking about with domain. Maybe you did some of that in an algebra class. All right, let's keep going. So this first section where we're talking about the definition of a rational expression, that's section 1.10.1. I didn't write that up at the top. You can just we can just call that domain. right, if you want to squeeze that into your notes. But we're just going to continue that. Let's do another example. So what is the domain? And we have x over x squared plus 1. Well, if you look at that denominator, all we care about is the denominator. That denominator can never be 0. If you have a negative number and square it, it'll be positive. So you'll have some positive number plus 1. So the denominator can never be 0. So what do you do in that case? Then the domain, the way you write it is just all real numbers. All right. So the summary for this section is set the denominator equal to 0. Factor and factor if necessary. So you might just be able to eyeball it to find the values of x to exclude. So those would be the values of x that make the denominator 0. So I'll put that in parentheses. Those that make the denominator equal to 0. All right. Okay, I'll go ahead and erase. We'll go to the next section. So this is 1.10.2, working with fractions. So I'm going to take you all the way back to like the 5th or 6th or 7th grade. I'm not real sure when you start finding common denominators and things like that, but this kind of stuff goes with you just all the way through math. So let's review addition or subtraction of fractions. So let's say we have 1/2 plus 1/4. What does that equal? Well, we need to get a common denominator. So what I want to do is multiply one or both of these fractions by a clever version of 1. All right, because you can multiply anything by 1 and it doesn't change anything. So how about if we multiply this first one by 2 over 2? That's a clever version of 1. So you would get 2 over 4 plus 1 over 4. And now we have a common denominator. We can add the numerator. So that's 3 over 4. So we spend a lot of our time just trying to get a common denominator. So let's do one with subtraction. Let's say we have 5/6 minus 1/10. Okay, so you can think of this, if you don't want to use too much brain power, you can always get a common denominator by multiplying the two denominators together. In this case, that would be 60. But we can probably do a little better than that. I can see that we also could get a common denominator of 30. So that would be if we multiply this front one by 5 over 5, and 1/10 if we multiply that by 3 over 3. So both just clever versions of 1. We would have 25 over 30 minus 3 over 30. All right. And again, if you don't want to do that work, just multiply 2 together. It'd be 60. Do that, and then we would reduce. So this reduces down to 22 over 30. Okay, and both of those, we can reduce those. They both have a common divisor of 2, right? So that would be 11 over 15. I do want to see the most reduced form of your fraction. All right, so let's review. Now the reason I reviewed that is because we're going to do that with polynomials. Review multiplication. Of fractions. So we just multiply instead of, let's not be technical. Let's just call it the tops and bottoms. All right, so the numerators and denominators. All right, so let's say we have 5 over 6 times 2 over 15. So 5 times 2 is 10 on top, 6 times 15 is 90. And then that would reduce down, we could cross out the 2 zeros, to 1/9. All right, that's one way to do it. We could also, if I want to show another way, over 215, we could, sometimes this is faster, we could cross out, so this 2 over 6 is really just 1/3. 5 over 15 is also just 1/3. Right? And then we multiply the tops and bottoms and you come up with 1/9. So you come up with the reduced answer right off the bat doing it that way. All right, hopefully that rings a bell, that you've been doing that all of these years. You certainly probably were doing that in 6th, 7th grade. And finally, let's review division. So division is really just multiplication. It's the multiplication of the reciprocal of the fraction. All right, so our example here is 2/3 divided by 5/7. So what you do is you take the bottom fraction and flip it and multiply. So this is the same as 2/3 times 7 over 5. So that's going to be 14 over 15. And that won't reduce any further. So our general form is, if you have A over B divided by C over D, that's A over B times D over C. All right. Well, that completes 1.10.2. We've got one more little mini section to go. And we'll call this 1.10.3, which is simplifying, which is the main part of this lecture. This is what we're trying to get to. Simplifying rational functions. All right, so for example, let's say we have 2x plus 2 over 2. So one way that you might think of that is, okay, I can split this into two fractions. How about 2x over 2 plus 2 over 2? It's the same thing, right? Then the 2's cancel out. 2 over 2 is just 1, so that's x plus 1. And there's no x in the denominator, so the domain would be all real numbers there. So I don't have to exclude anything. But another way to think about this, 2x plus 2 over 2, what you'll be doing, more likely, because as the problems get fancier, let's say we factor a 2 out of the top. We factor out the greatest common factor, we're left with 2 times x plus 1 if we divide that whole thing by 2, and then over 2. And then your 2's cancel, and you have x plus 1. So our procedure is factor, then cancel like terms, and then give the domain restriction. Which on this first one we didn't have a domain restriction because there wasn't an x or a variable in the denominator. All right, let's do one where we're going to go through this process. How about we want to simplify. That's our direction. Let's say we have 20x plus 10 over 30x plus 15. Okay, so let's factor out the greatest common factor out of both the numerator and the denominator. So out of the numerator, that would be 10, right? And you're left with 2x plus 1. If you're not sure, then you would just distribute that 10. That'd give you 20x plus 10. And on the bottom, you could factor out a 15. And if you do that, 15 will go into 30x, 2x, and then 15 over 15 would be plus 1. So then the 2x plus 1 over 2x plus 1 would cancel out. It's a thing over the exact same thing. Well, that's going to give you 1, which would be 10 over 15, and that would reduce down to 2/3. But there is a number that would make our domain, make our denominator 0. So we have to have a domain restriction. Set this parenthesis 2x plus 1 equal to 0. So 2x would be -1, so x would be -1/2. That's what would make the denominator 0. So our domain restriction is x cannot be -1/2. If it does, then if it is, then the denominator is 0, and that would be an undefined answer. So we have to restrict the domain. So this is part of your answer when you simplify. You have to include the domain restriction, or I will count off. Okay, 2 more, and then I think we're ready to go and work the homework. All right, our next example, we want to simplify. (10x squared plus 8x over 4x squared). Okay, so what can I factor out of the top? I think I could factor out a 2x. That'd be our GCF. And we would be left with 5x plus 4. Distribute to check. Now the bottom, 4x squared, you could actually rewrite this as 2x times 2x. That would be a useful way to write it. Or you could just leave it as 4x squared. But I just wanted to show you that if you wrote it this way, it really helps you figure out what will cancel out. And you're left with the simplified version is 5x plus 4 over 2x. But that's not the entire answer. There is a number that will make the denominator 0. What is that? Well, you can get this one by eyeballing. X cannot be 0. If x is 0, then the denominator is 0. So you could set 2x equal to 0, but I think we could probably eyeball that one. Okay, last example. We have a squared. So we're going to simplify this. Minus 4a plus 4 over a squared plus a minus 6. Well, how about we factor that? So it's good factoring practice, but we need to do that to see if we can cancel anything out. So we know it's going to be an A and an A, and then it'll either be 4 and 1 or 2 and 2, and I believe if I make it 2 and 2, and I make it minus and minus, then I would have a squared minus 2a would give you minus 4a, and then negative 2 times negative 2 is positive 4. All right, and the second one I've got, or the bottom, I've got a and a. I need a 1 in the middle, so I'm going to use 3 and 2. So how about plus 3 minus 2? Okay, so we can cancel that out as long as a does not equal 2. See how if a is 2, it makes that parentheses 0, which would make 0 times anything is 0. It'd make that whole denominator 0. So the final simplified answer is a minus 2 over a plus 3, but I've got another domain restriction here. What can a not be in my final answer? Well, a cannot be negative 3. So that's also part of my answer is the domain restriction. Negative 3 plus 3 is 0. So we'd have to include both of those. So include it when you cross one out, and then in the final answer, you have to include that one as well. All right, so the homework is worksheet 1.10. And just looking over that real quick, I don't see anything. I think you'll be just doing the kind of work that we were doing in these example problems. You'll be factoring and canceling. You know, we have some where you just do the where it says in. Let me go ahead and bring this into view. So where it says find the domain, all right. I just want you to put what x cannot equal. So you're gonna have to maybe factor and see what cancels out and see where the denominator is 0. All right, and then we're not working with not only variables here, but you're just gonna find a common denominator, divide, multiply, add, subtract in this middle section, and then in the last section, simplify. You have to simplify these down and include the domain restriction. So pretty much like the example problems. So hopefully you'll do okay on this homework, and those that you struggle with, you can watch the solutions video, and I will talk to you on the next one.